All right, everybody. So, welcome to Similarity. Um, Now, I think before we start getting into the similarity questions here, let's go ahead and just give a quick definition of similarity. Similarity is, so a good way to think about this is similar figures are the result of dilation. So getting bigger or smaller. So let's just do, let's see if we can do this real quick. Right, okay, so if I have a triangle, and I want to take that triangle and make it bigger. Now, these two are similar. So they're not congruent, but they are similar. So there's two really important conditions to similarity. The first condition that always has to be true for everything similar is that all angles are congruent. So when I'm trying to determine similarity, I have to know that all the angles are congruent. So for instance, if I take these, I didn't change any of the angles in these two triangles when I copied and then changed the size. So right now I know that all the angles are congruent. That's good. That has to always be the case. The second thing that you have to know is, wait, Aaron, I'm going to put a word in here actually. Wait a second. All corresponding. That all corresponding angles are congruent. That's actually really important. Okay, and then also all corresponding sides are proportional. All right, so what the heck then does proportional mean? So here's a good way that I like to think about it is think about it as multiplied or divided by the same number. Okay, so let's think about if this was 2, 2, and 3. And let's say, oh gosh, what do we think here? Let's say that this was 9. All right, well, that means that 3 got multiplied by 3. 3 times 3 equals 9 to make that. Well, that means that to find my other sides, I would also need to multiply the other sides by 3. Notice that we're multiplying by the same thing for all 3 sides. So now I would have 6 here, and I would have 6 here. So everything needs to be multiplied by the same number. All right, so if one side is 3 times the length of its corresponding side, all the sides have to be 3 times the length of its corresponding sides. Okay, now these two are similar. Like, yay, they're similar. We got it. There are a couple of tricks that you can do to check and see if two things are similar. Okay? And so the tricks are all about making fractions. So the first trick is going to be fractions between figures. Oh man, that figures, I'm gonna have to rewrite that because that doesn't look good. Fractions between figures. So I'm gonna match up corresponding sides. So I know that 3 matches up with 9. So I'm gonna make a fraction out of that. 3/9. I also know that 2 matches up with 6. So I'm going to make a fraction out of that. 2/6. Now, if the fractions end up being equivalent, then I know that they're similar. So watch. 3 divided by 9 can be simplified to 1/3. And 2 divided by 6 can be simplified to 1/3. I just simplify those and drop them down. Well, that checks out. 1/3 equals 1/3. And so I can say, yes, they are similar. Woo! All right. Now, the other trick number 2, sorry guys, I should do this. Let's we'll separate my note sections here. So I'm kind of drawing everywhere. All right, so trick number 2 is fractions within figures. All right, so let's go back up here to my original triangles. So now I did a fraction between the two. Let's do one within, okay? So I'm going to do, let's see how I'm going to do 3 divided by 2. 3 divided by 2. Now I'm going to go up here, and I have to go the same direction, all right? So I have to use the number in the exact same spot on the triangle and another number in the exact same spot on the triangle, right? So here and here, and then the same things here and here. So where I had 3 divided by 2, now I have to have 9 divided by 6. So see how they match up as far as how I 9/6. Now, if I simplify these, so there's a couple ways to do this. I could just put this in the calculator. I could certainly do that. So 3 divided by 2 would be 1.5. 9 divided by 6 would be 1.5. And you can just grab your phone calculator, do it on your computer calculator to make sure that I'm right, but I think I am. Now, that checks out. That's good. So I can say, yes, they're similar. So I can use either of those two tricks to make sure that my sides are proportional, okay? I can use the fractions between figures, or I can use the fractions within figures, okay? Don't try and mix and match. If you're gonna do between, you gotta do it for both your fractions. Okay, so now let's go check out some of these examples. Let's do this. Can I just, no, I'll do it later. All right, so we'll draw another line so we can keep everything straight. All right, or we can just zoom. All right, so this one says that the diagram shows rectangles 1, 2, 3, and 4. So really important thing here is it says rectangles. So I know automatically that all of these have all right angles. So the first condition for similarity is met here. Okay, so remember the first condition for similarity was here, all corresponding angles are congruent. So that's true. So now I can go and I can do my two tricks. For this one, let's try trick number 1. Let's try to make fractions between figures. Okay, so I've got short sides and long sides. So let's just highlight my short sides and long sides. Okay, so 20 is short, 18 is short, 40 is short, and 20 is short. And then 30 is long, 80 is long, 36 is long, 40 is long. Okay, so let's try to make fractions between figures. So let's do these two first. All right. Oh man, I don't like that one. So I'm going to do 20 divided by 18, 20 divided by 18, and 30 divided by 36. Those have to equal each other. Now I happen to have my phone calculator. You guys just can't see it. 20 divided by 18 is 1.11. whereas 30 divided by 36 is 0.83. So those are not similar. So it's not 1 and 3. Okay, so now let's try. Oh man, this is going to take a long time, guys. Let's switch gears. So for this one, we can analyze our own strategies here, guys. Going between figures for these two is going to take a long time because I would have to do 1 and 3, 1 and 2, 1 and 4, 2 and 3, 2 and 4. That's going to be a lot of different comparisons. So instead, let's go to fractions within figures. So watch this now. I'm going to do yellow over blue for all of them. 20 over 30, 18 over 36, 40 over 80, and 20 over 40. Now, let's see, 20 over 30 is going to be 0.66. 18 over 36 is 0.5. I'm just doing, you can just do this on your calculator, guys. 40 over 80 is 0.5, and 20 over 40 is 0.5. So all of them that have a matching number, those are all similar. So those two are similar, those two are similar, and those two are similar. All three of them are similar to each other. Okay, let's go do the same thing in this one now, okay? So I'm going to highlight short sides and long sides. So 6 is short, 3 is short, 7 is short, 3 is short. 10 is long, 4 is long, 9 is long, 5 is long. Now I'm just going to do yellow over blue again. 6 over 10, 7 over 9, 3 over 4, 3.75, 5. So let's do it on the calculator. 6 divided by 10, that's going to be, oh, why is it not doing it? 6 divided by 10. Ooh, you gotta learn to use your calculators, guys. 0.6, 7 divided by 9, 0.77, 3 divided by 4 is 0.75. Oh man, guys, none of them are congruent or similar so far. 3.75 divided by 5 is 0.75. Cool, so I've got matching ones there. So 3 and 4 are similar. The others are not similar to each other. Okay, let's work through this one real quick. So are the two triangles above similar? Select the best response. So remember, we need to know two things. We need to know that corresponding angles are congruent. And then we also need to know that sides are proportional. Now, first thing I want to look at is angles. Now, an issue that they're giving me here is that all I know is I know side lengths. I don't know any angles. So without knowing anything about any of the angles, it makes it really hard to say that these are similar. So I know that none of these can be true, but let's talk about each one. Holy cow, this is dangerous. We never, ever, ever make decisions based on how they look. Definitely not that one. Now, this is true as far as we can tell, but since we don't know any angles, we can't, that's rule number 2. That's this one, but we don't know rule number 1. And all isosceles triangles are similar. That's definitely not true, because all that means is that it has two sides that are the same. But I mean, we could have an isosceles triangle like that, and then another isosceles triangle like that, and those obviously are not similar. So that one can't be true. Now this one says that D is not proportional to A. Well, I don't know. I don't know anything about A and D, so that's really hard for me to say. So really the answer here, we are not given enough information. We have to know something about angles in order to determine similarity. All right, now finally, which rectangle is similar to a rectangle with length 1/2 and Okay, so it's 1/2 and 2/3. So all I'm going to do here, guys, is now this is going to get a little bit tricky. Um, so I'm going to use rule number 2. I'm going to go fractions within. All right, so I'm going to make a fraction out of this. So that's 1/2 over 2/3. Man, they're trying to get tricky on me here, guys. All right, so that's going to be 0.5 over 0.66. So let's do that real quick. 0.5 divided by 0.66. So that's going to be roughly 0.758. Now these, gosh, this one's tough. That's 0.25. What's 2/5? 2 divided by 5. All right, so this one's hard. 0.25 over 0.4. 0.25 divided by 0.4. That's 0.625, so it's not that. That's 2.5 and that's 2.66. So 2.5 over 2.66. Uh-oh, guys, it's going to be passing time soon. 2.66 equals 0.93. That doesn't work. Oh, gosh, but does it go the other way? Nope. All right. 0.25 divided by 0.33. 0.25 divided by 0.33 equals 0.758. That looks like it's the one. I know I went through that fast. If that's confusing, come ask me questions, okay? All right. Good luck on similarity.